Essentially, decision analysis is decision making under uncertainty. So somebody said earlier in the class, I won't pick on them, but somebody said, are we going to have to know probabilities? Yes, you're going to have to know probabilities, right? Because that's how we're going to capture uncertainty. All right. So really, what we're going to have in this process is we're going to have decision alternatives, and I'm going to give you a context in a second so you can apply this. You're going to have decision alternatives, things you can choose between, so to speak, right? And you're going to have possible outcomes. So one of your challenges is going to be when you read a problem or consider a situation is, what do we get to choose and what happens without our control, right? And essentially, at least initially, we're going to assume that every combination of alternative and outcome has a payoff of some sort, right? And of course, the outcomes, because we don't control them, they have probabilities associated with them, right? And so we're going to do some calculation of what's the best decision. We're going to make some assumptions that we're rational, that we're profit maximizing, and that we're going to choose the best, right? So the idea here is by having a formal process to make our decisions, while the result of the decision-making process may not always be a great outcome, we have a formal process to follow to make our decisions. Having the formal process is better than having an ad hoc process, is I guess what I'm trying to say. So that's kind of going to be the logic of what we're going to go through. So I'm going to give you a story problem first. We're going to work through it on the board, and then of course we're going to move to Excel after we work through one on the board, and then after that we're going to learn how decision trees work, and we're going to build decision trees, and hopefully we'll try to build these decision trees in Excel. Right, that's going to be where the rubber meets the road. I can see a break coming at that point. But let's see how far we can get. So here's the problem. It's by the way, we're in day 8, part 2, Introduction to Decision Analysis, and we're going to look at the Magnolia Inns example, which I apologize is a very American example. We have a city in the South in the United States called Atlanta. It's a very massive city, actually. It's huge. It's kind of the New York City of the South. It has a supermassive airport. You ever been there? Very, very busy. And it's getting to the point where it's full, right? They can't add any more flights. So at this airport, they are considering adding another airport to town. Well, everybody knows they're considering adding another airport to Atlanta. The thing that they don't know is where they're going to locate this airport. So it could be over here, and I think we're going to call it location A, or it could be in location B. But we don't know which place we're going to locate it. So and by the way, most of what we do in decision analysis is going to be strategic decision making. So being a strategic, being a hotel chain, Magnolia Inns, and thinking about this new airport, we would like to potentially buy some land near one choice of the new airport or near the other choice ahead of them making that decision, right? So the time element's important, right? Because once the decision is made, obviously the land in that area is going to increase in value a lot. So if we speculate, you can get the land for a lot cheaper price, right? If we wait till the decision's made, then the prices will run up quite quickly. Okay, so that's sort of the context of this problem. That's what it says, basically. So what else do we know? Okay, so here's what we know. We know that there's we're estimating, and again, we'll do sensitivity analysis on this later, but we're estimating there's a 60% chance that they're going to locate the airport at A. And therefore, since there's 2 possibilities, there's a 40% chance they're going to locate the airport at the other location, B. So the question facing us is, should we buy land around A, around B, both places, or do nothing? Neither, okay? And we have this table that's given to us of estimated costs and benefits of those decisions, okay? Everybody understand? Seems pretty good, okay? Coffee worked, right? All right, so let's take a look. So the first thing we're gonna have to construct, and again, we'll generally, it's a lot easier to do this in Excel, but we'll do it by hand once.
Can I ask you about last row, present value of future sales price?
Yeah, so all the time values of money are already taken care of in the table. It's basically my answer, I think, to your question, right? So that's all computed into that. So it's all sort of in present value dollars.
But that's a cost or?
Oh, so the present value, so this is the price, purchase prices.
Yes,
this is the
yeah, present value of future cash flows.
Right.
But the last item.
Oh, right. So this is if we buy the land at A and they build the airport at B.
And that's the value.
That's sort of the salvage value of the land, right? So we made the wrong decision. That's the loss. The difference between those numbers is the loss we're going to incur. So the land's still worth something, it's just not worth as much. All right? I'm going to cheat for a second because I want to do this in a way that doesn't confuse us later. Oops, that's the wrong spreadsheet. Let's see here. Just going to cheat real quick. Sorry, apologize for this. Okay. So we want to build what we're going to call a payoff table. And this payoff table is going to be sort of on one axis, the outcomes, so we need to figure out what those are, and on the other axis, it's going to be the decisions, or the decision alternatives, if you will. All right, so here's my table. I'm going to leave it open for now. What are the possible decisions, and what are the possible things that can occur that we don't control? That's the first thing we're going to do. So sometimes they call the outcomes, like another word for the outcomes would be the states of nature. Again, trying to indicate that that's not something that we as a decision maker controls. So what do we control? Those are the decisions. What's just going to happen we don't control? Those are the outcomes. So what do we put where? Okay, so that's
what we control.
Okay, right, so that's a decision, right? So we could buy at A, or we could buy at B. We could buy at both.
We don't have a budget constraint?
No,
okay.
We don't.
Or we don't buy.
Okay, or we do nothing, right? We'll say don't buy, okay? Don't buy at all. All right, so we got 4 possible decisions. My marker's giving out here. What about the outcomes? What can occur?
The expected value?
Actually, I'm just looking for a verbal description of what can happen.
So what can
the airport is built at A.
Exactly. Airport built at A, or
B.
airport built at B. Or we could just say site A is selected, site B is selected, right? Same
These
thing.
are the only states of nature. It cannot occur that there are both and built at all locations.
Probably not, because airports are really expensive and take a long time to build, so practically that's probably not going to be the solution.
Not built at all?
Yeah, they could decide that. I mean, what happens now, like they try to expand LAX in LA and the neighbors say, you know, I mean, this happens a lot of places. The town is too close to the airport, right? And so they say don't do it, but we're not going to consider that situation. All right, so we got the table. Okay, we got the axis. Now all we have to do is put a number in each cell. Okay? So if we buy at A and they build the airport at A, what is our ultimate payoff from that? Okay, so Michael suggests 31 minus 18. Anybody have any problem with that? So 31 is what it's worth, right? 18 is what it costs, right? So 31 minus 18, okay? So that's 13. What if we buy it today and they build it at B?
18 minus 6.
Okay. 18 minus 6?
Minus 18 minus 6.
Okay. How about 6 minus 18?
Yeah.
Oh, sorry, 6 is the select.
Yeah. So 6 is what the land at A is worth if they decide not to put the airport at A, right? They put the airport at B. And 18 is what we paid to buy the land. So we're down 12, right? If they build the airport at the other place. Okay? What about the B ones now? So we buy at B. Let's do this one first, it might be easier. They buy at B and they build the airport at B.
3 minus
Very good. 23, that's the payoff of having made the right decision, minus the 12 that it cost us. So that's plus 11. And what about if we buy at B and they build at A?
4 minus
4 minus 12. Okay, minus 8. Okay. What about if we buy at both, but they build the airport at A?
31 plus 23 minus 31 plus 4 minus 18 minus
31 plus 4, right? So they built at A, so we bought it both. So 31 and 4, right? Minus
18
minus 18 plus 12, because we spent for both. So what is that? That looks like, does it look like 5 to you?
5.
Looks like 5 to me too. Okay. And what about if we buy it both and they build it B? 23 plus 6 minus 18 plus 12, right? So that looks like minus 1. And what if we do nothing?
0.
Yeah, nothing.
What about the opportunity cost?
Opportunity cost is already counted in my present value.
Thank you. Okay. So what are the pros and cons of these different, so the goal, you can see, the goal is going to be to pick the best decision, right? What are the pros and cons of these various decisions? Which decision, suppose this is your money, your company's money, and it's millions of dollars. Okay, so there's 6 zeros after this,
You have to take
or
risk.
100 millions of crowns, or however you guys. Right?
You have to account
It
for
says
the
it's
probability as well.
Millions of dollars.
Yeah, millions of dollars. Yeah. I'm sorry. What did you say?
That you need to take the risk into account, so you have to count with the probability. So I would count the expected value of each choice.
Okay, yeah. So we're going to actually do that after. We're going to first, before we get to probabilistic decision making, that's going to kind of be the theme. But we're going to choose the decision based on some other criteria first. We're going to do non-probabilistic decision making first. So yes, exactly. So have you done this before? Oh, okay. So you did do this. All right. Did you do decision trees?
No.
Okay. So we'll get to that. So it'll be a repeat until we get to that part. So what's the pros and cons of these decisions? Which one would you take personally, I guess, if you had a choice? You choose buy both. I'm guessing a lot of people would pick that. Why would you pick that?
It's
It's the least risky one.
Okay. Well, it's not the least risky one, is it?
It is the least risky one because the spread.
What about this? Isn't this less risky?
But it's not. Yeah, that's true.
There is no profit anyway.
You didn't go to business school to pick this, right? Exactly, all right? So, right, between these three, it's the least risky one. I think that's one reason, right? The other reason is,
Highest revenue.
well, it's not the highest revenue, right? Over here you can make 13, over here you can make 11.
It's the maximum
But-
minimum
The
value.
least risk.
Okay, well, risky kind of means the spread between high and low, right? Sort of the standard deviation.
Or the least impact of the risk.
Okay, yeah, so that's what I was hoping you would say, right? Also, the downside isn't very big, right? Up here, you can have this, and up here, you can have that. So the downside is very high, right? So it's interesting we're picking this one, right? Because it looks kind of like a pretty conservative decision, right? But I think most human beings' utility functions, right, we tend towards being a little risk averse, right? All right, so there's different decision-making criteria you can use, right? We're gonna do the basic simple ones. There's one called Maxi-Max. It sounds like you've already learned it. We'll just run through it quickly, right? Maxi-Max. That way you can't complain if you get tested on it, if you don't know it, right? So what you do is, Maxi-Max is like the aggressive strategy, right? You pick them, you say, okay, what's the best thing that can happen in every case, right? 13, 11, 5, 0. And you say, of those best things, which is the highest? So it's the max, right? These are maxes, right? And it's the max of the max, right? So the max of the max is 13, so that would tell you buy at A. Okay? Then there's the sort of antithesis of that, right? So they call that the aggressive strategy, obviously, the what's the best thing that can happen. Glass is half full view of the world, right? Then there's the maxi min strategy. Okay, so you're saying, so the weird thing about this is, I think computer scientists must have designed these decision names, right? Because when it says maxi min, you actually do the min first and you do the max second. Okay, so it's like operations from the inside out, right? So what's the worst thing that could happen? Take the min, well, minus 12, right? On this decision, minus 8. On this decision, minus 1. On this decision, 0. And take the max of the mins, right? And you get 0. So what does that tell us to do?
Don't buy.
Do nothing, right? Don't buy. Right? So obviously that's tied up with being conservative, right? If you're extremely conservative, that's what you would do. All right? Those are easy. Those are obvious. Those are great exam questions, by the way, hint, hint. The next one we're going to do is minimax regret. This is easy to make mistakes on. You got to practice this at least once. All right? So to do regret, you have to compute a regret table. And it's like, how much would you regret making the decision you make given a certain outcome? Okay, how pissed off would you be, okay, so to speak, right? So I bet Bruce Denning, for example, regrets making a bet with David, right? Right? We were talking about this other professor who's a colleague of mine at lunch, and he made a bet with one of the students for 1,000 crowns, and he lost. And the fact of the matter is the guy's personality is he's very uptight about money. So 1,000 crowns probably seemed like a lot of money to him. So, right? And then when he came back and he saw these students again, he didn't want to talk to them about making any more bets. So we were joking about that. So how much do you regret, right? So the way to do this, I think what I'll do is I'll make a regret table, right? Because it'll be more straightforward. And we're going to base our regret table on the original payoff table in green, okay? And then we'll calculate the answer, all right? So the min-max regret table, right? It's also going to be a 4x2 table. And I'll double outline it to sort of indicate that, right? Right? So this is airport at A, and this is airport at B, and this is buy at A, buy at B, buy at both, do nothing. So this is our regret table. So what you do is you say, okay, let me see the best thing that can happen to me in either column, in either outcome. What's the best thing that could happen to me? What's the best thing that could happen to me here?
You buy at A.
You buy at A, right? If this occurs, the best thing would have happened would be buy at A, right? If this occurs, the best thing that would happen would be buy at B, right? Okay? So if you picked buy at A and the airport was located at A, how much would you regret that? Nothing, right? Why nothing?
13 minus 13.
Yeah, you made the best decision for that column, right? So you're not going to regret it at all, right? So, right? Oh, we'll get to the formula so you can get a formula. How about this one? Let's say you bought at B and they built the airport at A. How much would you regret that? Okay, the answer is 21. Look, you lost 8, right? And you could have had 13. Okay? So I'm thinking the formula should be something like 13 minus a minus 8, right? The best alternative minus what you got. So you would regret it by 21. Okay? Believe it or not, it's easy for me to mess this up because I don't do this that often. So you could have had 13, but you bought at both, so you wound up getting 5, right? They located the airport at A, you bought at both. You wound up getting 5. So your regret is 8. You could have had 13, but you did nothing, so you regret it by 13, okay? So this one is 13 minus 13, your regret was equal to 0. So those are your regrets for that option. What about the second column? Can we write down the numbers without calculating it? Maybe we should calculate it. What's the best thing that can happen in the second column? You buy at B. You bought at B and they locate the airport at B. Well, located the airport at B is the second column, so you buy at B, right? So your regret for this cell should be 0, right? Right? If you're doing the best thing, your regret should be 0, 11 minus 11. What about up here? Right? 11 minus 12, right? Or 23. 11 minus 1, or 12. And 11 minus 0, or 11. Okay? So that's our regret table. Let's calculate the max regret in each case. Again, notice that we're doing the operations from the inside out, right? So the max regret, 23, 21, 12, and 13. Okay? Now you take the min, finally, of the max regrets. All right? So it's like 3 steps. You calculate the regret table, you calculate the worst regret for each decision, you take the minimum of those regrets. The minimum of these numbers, obviously, is 12. So the decision would be buy it both. So actually, this minimax regret strategy sort of follows more what most people would probably pick, I think. I mean, you guys actually picked exactly what I would have thought most rational people would choose in this, right? Hedge your bets and buy land in both places. All right, very good. So we covered those. So the next thing is to incorporate probabilities. And as Mike was saying earlier, we've got this chance that there's a 60% chance that the airport is located at A. Where in this picture does that 60% chance kind of go? Sorry, Raphael. Where does that 60% go?
Right into the beginning of the table, like
Yeah.
should be weighted by 60%.
Okay, yeah, so what are you exactly going to weight by 60%? What are you going to weight by 60%?
Any part of the table.
Okay.
Weighted by 0.06 and
So columns or rows?
A column should be weighted by 0.6 and B column should be weighted by 0.6.
Very good. So I'm using decimal points. 0.6, 0.4, right? These are the probabilities that have been assessed. And we'll talk a bit about subjective probability, right? And then what do we do with those probabilities? Some product, right? We're going to take these probabilities and we're going to weight them by these payoffs and calculate expected payoffs, okay? So 0.6 times 13, 7.8, plus 0.4 times minus 12, minus 4.8. 7.8 minus 4.8 sounds like 3.0. Okay, one more time. 0.6 times 13, 7.8. 0.4 times minus 12, minus 4.8. 7.8 minus 4.8, right? These are, I know you hate these markers, Ahmed, sorry. These are expected payoff. Okay? Sorry, the picture is getting busy now. 4.8 negative, right? And 4.4 positive, so minus 0.4. Uh, 3.0 minus 0.4 positive 2.6. I'm going to have to go run for some new markers in a second. And of course, the weighted average of two zeros is going to be 0. So we got 3, minus 0.4, 2.6, and 0. Which one do we choose? The first one, right? We're maximizing the expected payoff. So when we get down here, right, we max the expected payoff. 3.0, which says buy at A. Okay? Most of the time for the rest of this analysis, we're going to work with the probabilities and compute the expected payoffs. Okay? You guys bring your laptops with you? You want to do some Excel on laptop? No? Okay. Do biologists know Excel?
Kind of.
Okay.
Engineers do.
Yeah.
I know Excel from my bachelor's.
Yeah, my brother's actually a
But,
biologist.
I really hate this.
You'll get better at it. It's not that bad. Okay? It's not that bad. I don't want you to get scared away from an MBA because of that. That's the only reason. Okay? All right. Let's do this in Excel. Are you guys ready?
So ready.
Okay, let's do it. So I got an Excel spreadsheet just below the thing. The problem's there. If we're careful, and if you get lost, I'll give you updated versions of this. Okay. Here we go. So we've got 4 decisions, right? Buy at A, buy at B, buy at both, buy neither. Okay? And I want to do this in a way that links the numbers up top to the cells down below. So it's not going to be pretty. There's no slick way to do this, but I want to. So later on I can change those numbers at the top, and then I can do some, some sensitivity analysis down below. So let's do that. So so that's why I left this thing. So this one is 30. Oops. This one is equal to 31 minus 18, right? 31 minus 18. Just get me to slow down if you guys get a little lost. Okay. 31 minus 18. All right. And this one is 6 minus, no, not 6.
4.
It was 4, right?
Yeah, 4 minus 12.
4 minus, we bought a B, right? 4 minus 12, right. C6 minus C4. I don't know any fancy way to enter these things, so we're just going to have to be patient about it slowly. All right? Oh, I hate that notation.
So negative puts it in.
That's like accountants do it that way. Very annoying. I'm a mathematician, not an accountant. We'll fix that in a minute. All right. Buy it both. So that was buy it both, but they build it at A, right? So that was 31 plus 4 minus 18 minus 12, since we bought it both.
You don't have to put in any parentheses?
No, not really. It's pretty simple. I mean, you could make it look prettier and say minus parentheses plus, right, the costs. But.
Maybe for your own record.
Are you into pretty spreadsheets, Jacob?
No.
Okay. All right. 0.
Okay, so
Not putting any function in there. Okay, so buy an A, but they build it B. So that's 6 minus 18.
oh,
It's on the board too.
yeah. So you buy an A, that means you
Right? So you only get 6 back for your investment because they built it at B, but you had to pay 18 for
Yeah.
it. Okay. Buy at B, this is when you make money, right? You get 23 back, but you paid 12. And then finally, buy it both, but they build it at B, so you get good money for B, not very good money for A, minus, and now I am putting parentheses. Just
for
to
fun.
throw you, just to bug you, Jeff,
Right.
mostly. All right. Okay. Minus 1 and 0. So does our table agree with what we had before? I think so. Let's do a little bit of prettying this up. And I'm going to center it. I'm going to make it a number. I'm going to make it currency. And of course it goes to Czech koruna. We can change this, so I will, but I really hate that format for the numbers. So how about if we make this English UK? Wow, that's really strange. Euro, ooh, still strange, right? Maybe I'll just stick with the numbers. All right. Very good. We could build all these functions, and I'll give you the answer with all this stuff we did on the board built into, built in. Let's calculate, let's put the probabilities in. 0.6, oops, not 0.6, 0.6. This professor is having trouble with the switch to Europe, okay? I use Excel too much. And my skills are very heavily ingrained in the United States format. All right, so those were the given probabilities. Let's compute the expected payoff in each case. So you know the function. It's our favorite function in this class. Sum product. Oh, once again, the professor forgets the semicolon.
Product.
It's only the second time today, though, I want to point out. All right. But the 800th time for the class.
C12.
So that's the weighted average, right? You're weighting 13 by 6 and you're weighting 12 by 0.4 and you're summing them up.
Oh, yep.
I'm anchoring them so I can just do this once and copy them down, right? So I get 3 minus 0.4 and 2.6. Again, I'm going to use the same formatting I have to the right there. So I'll teach you some fancy Excel.
And which ones do I anchor? I anchor just the probabilities.
Yeah, see, because I want to copy those down, right, Jacob? And I don't want those probabilities to change.
Yep.
But I want those payoffs to change. All right. So let's down here, maybe one row below, max payoff. Right, compute the maximum payoff. I'll bold that. So you know how to do that, right? Max. Okay. All right, so let's do some fancy Excel here. Something new just for fun.
I'm starting to like Excel.
Yeah.
And then we're going to build the decision trees in Excel. All right, we're going to pick.
Change professions.
I just want to fix it.
What I want is. Did you miss something, Erica? This one?
No, we're just ragging
discussing our
on
love
Excel.
of
Oh, okay.
Oh,
Got
his,
it.
His love.
his
my
love, her hatred.
Got it. I want to have a cell where I have the best decision in there. Best decision. So I can do some sensitivity analysis later. We're actually going to build a data table. So I want to have a cell where I can have the best decision. So does anybody know how I can have this print out in this cell, buy it A, buy it both, buy neither, whatever the best decision is?
VLOOKUP.
Yeah, so you could do a VLOOKUP,
Or
right?
match.
VLOOKUP's going to work if you take this column of data and you copy it over to this side, right?
Index and match.
Yeah, so you can use the other commands called index and match. Let's try those just for once, okay? Not on any test or anything, okay, just for future reference. So sort of generalized VLOOKUP, all right? So let's look at index first. I never can quite remember what way this works, but I actually think we want to do match first. So let's do match first. So the way match works is it looks something up. In this case, we're going to look up the max profit, max payoff. And we're going to put a semicolon after that. Yes, finally, almost on the last day. We're going to look that number up in this range. All right, and then we're probably going to add this last argument. I think this last argument is it false match type? We want it to be an exact match. Let's do, you know what the problem is? Semicolon, how quickly they forget. Yes, so the match type is an exact match. So you can put a 0 in for that last argument. Or you can do it, my friend Ahmed does, and push the function button, right? That always helps, right? So what this is going to give us, match, is it's going to take this number, it's going to look it up in this table, and it's going to give us back the row in that table where that number appeared. Right?
What does a 0 do?
The 0 just says, remember how sometimes in these lookups we can go between the rows? The 0 makes sure we don't go between the rows.
Like when you're putting.
0 makes 0 tolerance, exactly. 0 matches it exactly.
Look what to match to, so it says exact match.
Exact match. So we want this number to match. We know this number came from this table, right, Jake? Because it's the max of these numbers. So it's got to match exactly. The only tricky thing is when there's a tie, it's going to pick the first one, I think, when there's a tie. All right, so that gives us the row in this range where the max occurred. That's good, because now we can go back and edit this function, and we can use the index function on top of it. Okay? And so we're gonna look up in this range. That's our array. Put a semicolon. We're going to look up whatever comes back from the match function. So it's going to be a 1. It's going to tell us buy at A. And I think that's all the arguments we need here for our index command. 2 arguments. Did I put a semicolon in between? Yes, my God, I did. All right. So again, the match command tells you what row the optimal occurred. And then we look over here and we say, okay, let me report back whatever's in that row over here. Okay? So you're going to see how beautifully this works by a day.
Pretty snazzy.
Okay? So it's like a more sophisticated version of VLOOKUP, basically. Sometimes very useful, I have to be honest with you. So here's the way to test your spreadsheet. Suppose there's a very low probability that they locate the airport at A. What should you be doing? Suppose there's a very low probability that, oh, we have to fix one more thing first. Sorry.
One should be one minus the
Very good, Michael. We have to fix one more thing. We have to fix this cell right here. It has to be equal to, don't forget to do this, 1 minus this cell. I did think of that and then I forgot it again. That has to be equal. So basically when we change this cell, this one will automatically be adjusted, right? Because of course, one thing to keep in mind is that all these numbers, these payoffs and these probabilities are estimates. So we want to do some sensitivity analysis on them.
Oh,
All right?
what was there?
Yeah.
You just had to add to it, right?
Okay, so what happens if the probability of buying, let's go higher first. What happens if the probability of buying, locating at A goes higher, like to 0.9? What do you suppose we should do?
buy days.
Buy at A. Sure enough. Suppose the probability of A goes to 50-50. What do you think we should do? Neither? Let's see what happens. 50-50? Buy at both. Suppose the probability of locating the airport at A goes very low, like 20%. What do you think we should do? Buy at B.
Oh,
Bingo. Okay. Not
Excel's great, isn't it?
not working?
No, it's awesome. I've just never used it before. This is awesome.
Okay. Yeah. It's cool. All right.
I'd run my life on this.
You guys remember data tables? Let's build a cool data table now. All right. Ready? In the first column, we're going to put the probability of locating at A. Locating. I tell you I was a terrible speller. Locating airport at A. At location A. That doesn't sound grammatically very. Please, Jacob, take pity on my grammar. 0.0, 0, 0, 0,1. Why don't we go up by 0.05? 0,05, and we'll go up in increments of 0.5, so we get a nice fine-grained table here, all the way up to 1. Okay.
Right.
All right.
To dragon it?
So I'm starting that on line 21, by the way. We should have left another space, but it's okay, we didn't. So what we'll do is we'll put the
Going to 1, I think.
max,
Yeah, obviously.
we'll put the expected
Oh, it's a probability. Yeah.
payoff here, and we'll put the best decision here. So remember the first weekend of class? Seems like so long ago now, right? 2 weeks ago. We were building data tables. Remember the format? You set up the axes of the table, and then you say, expected payoff, let's link that to cell D18. That's going to be our expected payoff.
That's
And-
the expected payoff?
And it's the expected payoff. Yeah, it should really say,
According to max
It should say maximum expected payoff is what it should say. So let me change this other label up here to make you happy. The max of the expected payoffs, and I'll change this one too to make you even happier. Max expected payoff. Okay, should agree. I agree. It's confusing if it doesn't. All right, and the best decision will link to cell D19. Okay. So what I'm going to do is I'm going to center all this stuff so it comes out pretty the first time. All right, so you guys remember how to do a data table now? I'm sure you don't. Right? What do you highlight?
Everything.
Everything, meaning the whole dang thing, like that?
Whoa, too far.
Okay. What do you highlight?
What, from 20 down?
Not from 20, but from...
The first data point. No,
Yeah.
including the thing. Oh.
Yeah, remember you got to get those functions that you entered right in the top. So you got to go from 21 all the way down. Okay, just like that. So you highlight that.
Okay.
Data, what if analysis, data table, and then we don't use the row input
What
cell
if? Where's the what if gone?
Data.
Oh yeah. Yeah.
under data.
And then which one? Data table. Yep.
And then what do we plug into the column input cell? You remember?
Columns.
What are we changing in our data table? The probability of?
Something happened.
So probability of something happening, good. That gets us down the road. The probability of what happened? B17. Thank you, Michael, for ending this discussion. B17. Right? Michael says, I've had enough of this. B17. Okay? Very good, Michael. B17 is it.
That's it.
That's it.
No rows.
That's it. And here you have a beautiful data table.
Jesus.
What do you have in cell
Let's take a look at it.
C21?
C21, I have the reference back to D19.
Okay.
Okay? And, right? So here's what happens, right? You can't see the whole table, but if the probability of locating the airport at A is very low, right? Then the probability of locating it at B is very high. So we're buying at B all the way up, right? At some point, for a small range in the middle, we're hedging our bets and buying at both, right? Once the probability of locating the airport at A gets high enough, we're buying at A, right? So, again, if you want to know about sensitivity, right? I think if you were unsure, I would feel pretty, much less confident about this, but if you got evidence from the board or whoever was making this decision that it was more sure for one way or the other, maybe you'd lay all your dollars in one site or the other, right? In the middle, it looks like you're going to hedge your bets. Also notice this, as the probability gets higher to locate at B or higher to locate at A, notice what happens. Your expected payoff is growing on both sides, right? Your expected payoff is growing. When you're more unsure, your expected payoff is lower, right? So there's sort of a saddle point thing going on here with the strategy.
Don't want to be dumb, but why did you only put in the column thing in the what if table? Like,
What?
can you explain to me what's happening when you press the
Yeah,
column
so don't forget that this is a one-way data table, and we only have data in the column that we want to do sensitivity analysis on. So we're only doing sensitivity analysis on this one cell.
Okay.
Remember, if we change this, this automatically changes, and everything else changes. The way we set this up, everything else changes. So if we plug in different values here, we get different values in these two cells. Right, and so this is a one-way table where the data's in the column.
So you're just telling it where the data is.
You're telling it where the cell you want to plug in these values is,
Right.
and you're looking at the responses, right, to these two functions, to those perturbations. Very nice feature. All right? All right, are you ready to build decision trees if there are no more questions on this particular thing? This might not work on Mac computers. Again, I apologize, okay? I got some bootleg software for you here today, so let's see. And Juraj, I don't know. We'll see if it works, all right? So if you go back to Blackboard, you can see there's a tool here called Tree Plan. There are many decision tree growing tools in the world. Okay, Tree Plan is just one of them. I happen to steal this add-in, or borrow it, let's just say. Let's just pretend like we're doing a trial of this software. We're thinking of buying it for our companies, all right? So we're not actually doing anything illegal, okay? All right? So I'm going to right mouse click Tree Plan and save it to my desktop. All right? There's going to be a little bit of gyration here. Actually, you never have to build a decision tree in Excel, so don't stress out about that. It's not something you ever actually have to do. But it is kind of nice. And by the way, that analytical solver platform I talked about earlier that we're supposed to be using for this class that goes along with our book, that has a tree drawing tool in it also. I'm killing the text, so we get that out of the way. All right, so notice that on my desktop somewhere, I have the Tree Plan add-in now downloaded. Where did it go? Here it is, right here. So we haven't ever seen this before, but an add-in for Excel is, again, a piece of code that kind of works with Excel to do some specific job. So the first thing you need to do is you need to tell Excel that you want to use Tree Plan.
Or you double click it.
Okay? You could double click it. The way I would traditionally do it is to go to File, Options, Add-ins, File, Option, Add-ins, and after you get there, there's like a little Go button at the bottom, Manage Excel Add-ins, Go, and you get to this little window where the solver and the analysis toolpack we've used before are, and you browse to wherever you put your tree plan. There it is. It has a certain extension that Excel knows, XLA, and I'm going to select it, click OK, and now I have Tree Plan in my list of add-ins. Ahmed's right, you could probably just double click it and Excel will figure out that you want to use it. All right, I clicked OK, and now I have a new menu item here called Add-ins that wasn't there before. Okay? Again, this is kind of an old piece of software. Can you add it, Michael? You can. I think it kind of works on Macs.
Actually, this is the only thing that is less difficult than on PC. We just click on the add-in and it's there under the tools.
Beautiful, beautiful. Right? It's written under an old version of Excel, so let's keep our fingers crossed. So here's one thing you want to do about every time you do anything right now. Save your file, okay? So I'm going to save my file right now. I do have the answers, so, but I don't want you to lose everything. All right? All right, so let me draw on the board first, and then you'll see what we're going to do. Okay? We can represent decision analysis problems as decision trees. All right, so these are a little bit different than the trees I was talking about yesterday when I was talking about classification and regression trees. Actually, classification and regression trees we were talking about yesterday. So this is a little different. So decision tree, let's see what I got left in the green. Decision tree, and where this is going to be powerful, more powerful than the payoff table approach, is that we can do multi-stage decisions. And what we're going for is, you know, by the end of tomorrow, is a two-stage decision problem, which is a lot more interesting. So a decision tree has two types of nodes. First of all, it's sideways. It looks like this, okay? A decision tree looks like this. It grows sideways. It has nodes and arcs, right? But we think of this first node as the root node, right? We think of these branches that have endings as leaves, okay? So you'll hear me refer to that in those terms. The squares, very important, represent decisions. I forgot how to spell that right for a second. And those round circles represent outcomes. Okay, and you'll see that when we draw it in Excel. And of course, outcomes have probabilities associated with them. Decisions do not, right? Outcomes and decisions can have payoffs and costs associated with them. So our decision tree, and also, by the way, the flow sideways kind of indicates how things are happening in time. So do we get to find out first where they're building the airport, or do we have to make our land decision first? Land decision, Okay, so we have a decision first. What are our options for that decision? Okay, we can buy at A, we can buy at B, we can buy both, or we can do nothing, right? Or buy nothing, right? So those are our decisions. We have 4 branches. And then, if we buy at A, what can happen?
Build at
Or build at B, right? So build A, I'll just say build A, and you'll know what I mean. Build B, sorry, I gotta get rid of this red marker. Right? And build A, build, why don't we make it even easier? Why don't we make this even easier? We'll just say A or B, and we know what that means. If we buy a B, it could be A or B. If we buy both, it could be A or B. And if we do nothing, it doesn't matter. So I'm not even going to add anything to that branch down there. Okay? So this is essentially our whole decision tree for this first Magnolia problems. Okay, we're going to draw it in Excel in a second. I'll just put on some costs just to remind you, right? If we buy at A, this is minus 18. If we buy at B, this is minus 12, because this is a maximized profit tree. If we buy at both, this is minus 30. If we do nothing, this is 0. If we buy at A, if they decide to locate the airport at A, then we get 31 back. If they locate the airport at B, we only get 6 back, right? Here, if they locate it at A, we get 4 back. If they locate at B, we get 23 back. Here, if they locate at A, we get 31 from A and 4 from B, 35 back. And here, if we buy both and they locate at B, we get 29 back. All right? And so you'll see at the end, there'll be these little triangles, which are like the leaves of the tree. And what it'll do, once we put these costs on there, it'll calculate the numbers that we're familiar with, right? For example, 13 minus 12 minus 8 plus 11 minus 30 plus 35, 5, minus 30 plus 29, minus 1. So these numbers here should look familiar to what we already had over here, right? And then this last leaf down here, right, has a 0. The other thing I didn't put on here yet is, of course, the probabilities, right? This one is 0.6, this one is 0.4, 0.6, 0.4, 0.6, 0.4. And one thing you can see here is these probabilities are the same in all decisions for us, but they don't have to be. They don't have to be. We'll get to more general cases soon. Okay? So that's a decision tree for this problem. I'll show you how to solve the decision tree in a minute. Let's try to give it a shot to draw in this tool. Alrighty. Okay, so under add-ins, there's this thing called decision tree. Again, I would save often, save early, and save often. Okay? So if you do decision tree, it's going to say, I want you to buy me. Okay? We won't be using it for 30 days, so that's good. We're not really breaking any rules. I'm going to say I agree. Once I get past that, I'm going to say I want a new tree. Now notice where my mouse is. Very important, I'm to the right of everything else in my spreadsheet. Okay? Right?
Yeah, mine downloaded, but the ribbon doesn't pop up even when I customize the ribbons.
You know what it might be? It might be your security and you might have your macros turned off or something. Right? If you go to File Options, and in here somewhere, go to Trust Center. Do you have that? File Options, Trust Center Settings.
Yes.
Yeah. And
disable all with notification?
Let's see here, look at macro settings. I don't know, some setting in here, sorry.
Visual Basics.
Visual Basic settings?
No, I don't know if it's written as Visual Basic.
Maybe add-ins. What's the issue?
I think they're being blocked out by their settings on Excel. Because this is like a foreign code. One time, a long time ago, my Excel got a virus. Your Excel can get a virus, right? And the virus is in some VBA code that somebody wrote that, right? I used to teach VBA programming in Excel a little bit, a while back. So, all right. Do you find anything, Erica? Yeah?
No. Maybe,
So it doesn't
maybe
show on your
protected.
ribbon? Is that the problem? Yes. You gotta close it.
Yeah, try that. Try saving it. Try saving it, Michael, and then closing out all the way from Excel, and then reopening it.
I had that issue.
Cause my crystal ball, I was able to see.
Yeah, try
remove
saving.
in real time.
Yeah, try saving it, closing out, and reopening. That sometimes works.
Crystal ball. I know, I just want that up there.
Or just Control Shift T.
Could be in a different place
Okay,
too.
that worked.
Does that work?
And it brought my crystal ball back.
Okay, good. All right, let's give it a shot. So once again, put your mouse in column F for further over to the right. Hit the decision tree. Agree to the things. Hit new tree. When you do, boom, you get a little baby tree. Okay? This is not the smoothest running software, okay? So the tricky thing is, you see when it drew this object in there, it put a bunch of cells with zeros in them. The whole trick here is to sort of know which ones have functions in them that you shouldn't mess with, and which ones you're actually able to add stuff to. So it's a little tricky, okay? All right, the first thing is we're trying to draw that tree on the board. We have 4 alternatives, not 2. Okay, so I'm going to change this so we have 4 alternatives. So the way you change it is you click on this. You click on the node. Okay, so you can actually select the node, not the cell, but the node that you want to change. Okay, just like that. You save, like I mentioned, before it crashes, and you say decision tree again. And now it knows, since you're on that node, that you want to do something with that node. I want to add a branch. Okay, now I have 3 branches. All right. Again, I'm going to select that node, and I'm going to say decision tree again, and I'm going to add another branch. Okay. So now I've got 4 branches. I'm going to save again. Okay. I'm not joking about the instability of this, by the way. All right. So my decision here is buy at A. My decision here is buy at B. My decision here is buy both. And my decision here is buy neither. All right. In this cell right here, I4, I'm going to say equals minus 18, minus B4. In this cell, I'm going to say equals minus C4. And in this cell, I'm going to say minus B4 equals minus B4 minus C4. So again, that's where the costs of these decisions are going into play. Okay? I'm linking everything back to the table. Now you might be noticing that there's a number inside this square that's changing as I'm entering the data. And make me go back if you're lost. Right? It now says decision 4 is the best decision. Well, look at the payoffs of these 4 decisions right now. Why is decision 4 the best decision? Yeah, everything's negative, right? Decision 4 is the only one that's not minus, right? So everything's negative because all we have included are the costs, not the payoffs. So right now that says take this bottom decision, okay? So that's automatically updating as we enter information. Okay? Did I go too fast? Does anybody need to see?
One more.
Okay? So these things here that I typed in for the alternatives, they're just labels. Okay? They're just explanatory labels.
Link to which cells?
Yeah.
Right?
Link them?
This one is linked to B4, but I put a minus sign in front of it, Michael.
Ah, that's
Okay, that's why.
I see.
Yeah, because yours was probably pointing to 1, right? This one's linked to C4 with a minus sign. The minus sign is minuscule. And this one is minus B4 minus C4 because we spent money on both.
Ah, sure. And the bottom just says 0.
The bottom 0, yeah, we're not going to really do anything to the bottom. We're actually done with the bottom.
Okay.
Okay, so again, save. Not kidding about that part. Now we're going to add the outcomes. So we want to add the outcomes at the ends of the branches, right? So what we're going to do is,
Can you come back?
okay,
No, can you just
okay. Where do you need?
where does the minus 85?
It's the amount of money we spent on the parcel of land at A,
Okay, thank you.
right?
By both.
Right.
By both.
By both is the amount of money we spent on both. Okay? You can just put a number in there if you want, but it's nice later if you want to do sensitivity analysis to have it linked back to the table. So, David, it's minus B4 minus C4. The minus signs are really, really small. I apologize. Okay? All right? All right, so let's put an outcome node on here. So this is big. I'm going to select the leaf, just like I selected the node before. So I've got the leaf selected. Again, I'm panicking here. I'm going to save again and go decision tree. Change to a decision node? No. Change to an event node? Yes. How many branches? 2 should be perfect. Okay. All right, you get these little weird errors, like the clipboard cannot be emptied, but yet it eventually works. Okay, so let's see what happens here. I'm going to change these labels first. This is airport located at A. Spell airport correctly. And this one is airport located at B. Okay, now one thing you'll notice about outcome nodes is they have payoffs. You can change these numbers, but they also have probabilities, 0.5 and 0.5, right? So we're going to have to change these numbers. So we're going to do this real carefully. All right, let's do the probabilities first. And actually, before I do that, I'm going to go back here and change my probability back to 0,6, right? Because that's where we started, 0,6. So the probability is in cell B17, it looks like, the one we want to use. Okay? So I'm going to say equals B17, and I'm going to anchor that for reasons you'll see later. And you'll notice once I enter 0.6 here, I get an NA here, like an error message, right? And what do you suppose the reason for that is? Exactly. There's some kind of a test inside, very good, there's some kind of a test in the system where these probabilities have to sum to 1. So what we'll do is, we'll say 1 minus B17 in this one, and I'll anchor the B17 again, so that, right, this is going to save me time actually later, I think, I hope. Okay, so now the numbers are back, right?
How come I got 0.0?
Well, because we changed it to 0.2, I changed it back to 0.6.
Oh, okay.
That's a cell that we're going to do sensitivity on, or we already did. All right, so what about the payoffs? Right, well, if they locate the airport at A and we bought it at A, we get big money, right? We get 31, so that's equal B5, right? And if they locate the airport at B, but we bought at A, we only have 6, right? So now you see this branch is beginning to look like the branch down here, right? Payoff of 13, payoff of minus 12, right? Expected payoff of 3. And it turns out the decision tree has now switched the best decision to buy at A, right? Which is in correspondence with what we had before. All right. Okay, so here's the big daddy. Did you get all that? Okay. I'll wait a second. Take a breath. Anybody need to see any formulas or anything?
Yeah, the one.
What's in J6?
What's in J6? This one right here got calculated.
I have minus 15.6.
Yeah, so
So we need to run the.
you should not have changed that cell. That's one of those ones. Minus 15.6. Oh, well, you might have minus 15.6 if you have something over here different.
0.
Okay, so this one is supposed to be B5.
Oh.
Okay,
I didn't catch that either.
yeah. And this one down here is supposed to be B6, I believe.
Yeah.
Did it fix on it?
Yep.
Okay, great. No problem. All right. So what we're going to do now to save time is we're going to attempt to copy this whole branch from here and paste it down here. This really bothers Excel, right? This will crash it, all right? So this is where you, yeah, this is, save again. This is where you really need to save, okay? But it's nice because if you're building a really complicated tree, which we'll do later, this is nice. So I'm going to select that node. I can, just the node, not the cell. There we go. Select the node. I'm going to save the outcome, right? Just this one node right here in K. And I'm going to say decision tree, and I'm going to say copy subtree. Okay, that seemed like it worked. Then I'm going to go down here to this leaf. I'm going to try to select the leaf. I guess I have it. I'm going to go back to the menu and say decision tree, and now I'm going to say paste subtree. Okay, so it's a very manual process, not very click and drag oriented, very old school. All right, some intermediate errors, but guess what? It copied and pasted. My Excel is still open and functioning. Because of the way we entered the probabilities, they're already there. The only thing that's not there are the payoffs. You see that? The payoffs are both 0, so we need to fix those. All right, you guys with me?
Can we pause just one second?
Okay, paused, okay.
Good to go.
Okay, all right, let's get the payoffs in there. If we buy at B and they locate at A, guess what? We lost money. We only have $4 million, so that's C6. If we buy at B, but they locate at B, we're in the money. This is B. This is C5. Okay, and there's our friends, minus 8 and 11, like we had before. Expected value minus 0.4. Right, so one more branch to copy, and we'll be done. All right, once again, I'm going to select the node I want to copy. I'm going to remember to save my tree. I'm going to say decision tree. I'm going to say copy subtree, just like before. Seems like it's working pretty smooth. Before I do this again, I'm going to go down to this leaf, select it, decision tree, and paste subtree, just like before. Okay, and yes, we got the last branch. I'm just going to fan out for a second. I'm not quite done. I just wanted you to see the whole tree. Okay, there it is in all its beauty. Voila! Right? Looks cool. All right. Again, pre-plan is not my favorite software on earth, but it works. A little clunky, right? So we need to enter the right payoffs in these two cells. So the payoff is if they buy at both and they locate at A, 31 plus 4, B5 plus C6. So this cell right here should be B5 plus C6. If I have that correct. B5 plus C6. B5 plus C6. And this one down here is equal to C6, B5 plus C6, B6 plus C5. B6 plus C5. I feel like I'm at a bingo game or something. Right? B6 plus C5. All right, and there you see the expected value of that branch is 2.6. So the way the software works and the way you solve a decision tree by hand, and I apologize for this being so slow, is at any outcome node, so you start from the leaves, and what we're going to do is we're going to do a process called folding back, basically. And you say at any outcome node, I take the expected value, or the weighted average, right? 0.6 times 13, 7.8, 0.4 times 12, minus 12, minus 4.8. So the expected value of this outcome is 3. 0.6 times minus 8 is minus 4.8. 0.4 times 11 is 4.4. Minus 4.8 plus 4.4 is minus 0.4. 0.6 times 5 is 3. 0.4 times minus 1 is minus 0.4. 2.6. And of course this one's 0. Right? So at any outcome node, you take the weighted average, and then at any decision node, you prune off the worst, you prune off all but the best decision. So the best decision of these 4 looks like 3, so I would cut this one, cut this one, cut this one, and my best decision is decision number 1. Okay? So the folding back process is analogous. And the decision tree is doing this for you, right? There's that expected value, there's that expected value, right? And it's saying, okay, let me cut off all the branches except for decision 1, and the expected value of the problem is 3.0. Okay, so that it's sort of doing the folding back in a built-in way, right? And just so you can see its function, I'm going to make this a little smaller, a little harder to see, but let's do some changing of this probability now. Remember, if it's near 50-50, right? Something happened, didn't like that. What did I mess up here? 50. Oh, forgot the comma. Back in the United States already, sorry guys. 50-50, right? What happened? It moved to buy both. You see that? Expected value is now 2 for the tree, and the decision is decision number 3, buy both. So because we took the time to link the tree to the data, we can do this stuff. And if the probability of locating the airport at A goes down, let's say to 30%, right? Now we're back at decision number 2, and that's to buy only at B. Okay, so you see how that works? So the tree actually has a set of Excel functions built in. It's dynamic. I wasn't joking about the saving, by the way. It's very frustrating when you build a big old tree and then your Excel crashes and you lose the whole tree. So if you're using this, don't forget to save a lot of times. All right. Let's see. We did most of this example. Are there any questions right now? General questions or anything? All right. I guess before we quit, I'm gonna do 2 things. I'm gonna tell you about one important calculation that's a little tricky to make, and we'll talk about that. I'm gonna go back to 0.6 and 0.4. Oops, 0,6 and 0.4. Then I'll show you about one more example that we will not cover in class, but of course I'll give you the answers. One called SciTools. And then we'll take a little break, and then we'll talk about this last business after the break. Okay, so if you're wondering when a break was going to come, it's going to come in a minute or two. All right. So one quantity that I like to ask about on exams is called the expected value of perfect information. So this can be a little mysterious. So let me talk about it for a second. See how my blue is doing a little better. Expected value of, very important here, perfect information. So one way to think of this, EVPI is how much would you pay a consultant to know exactly what's going to happen? Okay? How much would you pay a crystal ball to figure out exactly what's going to happen? So to calculate the EVPI, you need two quantities. You need, no good, you need the expected value with perfect information. So notice this is of, this is with, okay? I didn't name these things, I apologize for their almost exactly the same name. Minus the expected monetary value, right? Or the expected, or just the expected value we already know, okay? Which in our case is 3.0, all right? So that's the expected value of this problem right now with these probabilities, right? Okay, so the main thing is we have to know what the expected value with perfect information is, okay? So there's a little bit of a weird quantity. The way you think about it is as follows. Suppose you knew they were going to locate the airport at A. What decision would you make?
Buy it.
Buy at A. You wouldn't bother with B at all, right? So if they locate airport at A, I would buy at A. And I would receive how much money? 31, but I had to buy it, so it's 31 minus 18 for a net of 13, right? If they locate at B, I would buy at B for the same logic, right? 23 minus 12. Right? Payoff of 11. So if I had perfect information about what was going to happen in the future, I'd make exactly the right decision and I'd get this much money. Same thing over here. Okay? So that's what I mean by perfect information. All right? Now what about the expected value business? Well, according to what we know, I'm going to erase these equal signs and put them up here. According to what we know, this is happening how often? 60%, right? Our prior belief is it's 60%. This is happening 40%. So take the weighted average of these two numbers by these weights, right? You get 7.8 plus 4.4, or 12.2. 12.2 million represents the expected amount of money I would get if I knew how to make the right decision in every case, right? The odd thing is I think, intuitively, is I'm only going to make this decision likely one time. But the way we think of it is, if it was happening over and over and over again, and in each case I knew what was going to happen, right? I would get 13 60% of the time, and I would get 11 40% of the time. So the average or expected value would be 12.2. that's the expected value with perfect information, 12.2. The expected monetary value, we already know, is 3.0. So that means 9.2 is the EVPI. Right? Again, 9.2 million is the most you would pay to know exactly where they're going to locate the airport. Okay?
If you pay all of it, then you have zero left.
That's right. That's right. If you pay all of it, you have zero left. So that's like an upper bound, an absolute upper bound. That's right. That's exactly right. Like with no information or with only the information we have is one way to think of it. We expect to return 3.0. If we had perfect information, we expect to return on average 12.2. So how much would you pay to get closer to that perfect information? You pay up till 9.2. Okay, that's the logic.
Where did we get the 3.0 from?
We get the 3.0 from the problem itself. Remember, we solved it in the table and we got 3.0, and we solved it here, we got 3.0.
Oh, okay.
So it doesn't look like 3.0, but it's 3. Okay, it is 3.0. So think of the problem is we have no information, or we have what we have, right? That gives us expected value. Now, how much would you pay to get better information, right? Well, the most better information is worth to you is 12.2.
Can I know, Rafael just asked about where did you get the free from? We know.
Yeah, so remember the original problem right here? The 3.0 is the expected value of the original problem, right here. Don't forget to change your probabilities back to 0.6 and 0.4. My recommendation is to sort of try to figure this out once, because you'll figure out the tree from reading the problem pretty easily. You might make a small mistake here or there, it's not a big deal. But the EVPI takes a time or two to sort of sink in to practice. Let me show you one more example real quick if there's no questions on this. And we're not going to go through the whole example, but I'll just give you an idea. And of course, I'll give you the answers later. Then we'll take a little break. So in this side tools example, and you'll see, I'll give you a little bit of the background, and then I'll ask you a couple questions to make sure you're getting it.